Jake, are you able to hear us?
Yes, I can hear you. Can you guys hear me?
Yeah. If
Yep.
you can get a video, look at you. Jake Plus.
Okay, are we ready to go? I can go ahead and hit broadcast.
We are ready.
Ready? Okay. Welcome, everyone. Let's see who we've got. Here we go. Got about 16 attendees so far. Give it another minute. Up to 29. Hoping you can hear us. Go ahead and maybe put into the chat session that you can. I'm not seeing the chat. Or even into the Q&A. Go ahead and add to the Q&A. Okay, chat's disabled. I can hear you. Okay. All right, let's go ahead and get started. My name is Stephanie Aden. I'm the Executive Director of AIA Spokane. Welcome, everyone. We have a big crowd that's joined us. I think we had over 65 people register for our current and newest remote live and local presentation, which is the new medical school for UW and the Gonzaga University Regional Health Partnership. Today, you'll be getting one HSW credit, and what I need you to do if you're an AIA member is go ahead and email office@aiaspokane.org with your member number and your name, and I'll go ahead and record the credit. We're excited to have our presenters here today. We've got representatives from CollinsWoerman, McKinstry Company, as well as Boughton Construction. I'm going to leave those introductions to our moderator, John Eckert, because I know we have a really long, good presentation for you, and I want to make sure that we get that kicked off as soon as we can. We really want this to be interactive. So in the Q&A area, go ahead and submit your questions, and then John will pose those as they make sense throughout the presentation, and we'll allow some time at the end as well. So normally I kind of go through a program description as well as the learning objectives, but in the essence of time and all the material that we have to present, I'm going to go ahead and kick it off to John Eckert, your moderator, who's with CollinsWoerman. So John, I'll go ahead and stop sharing my screen and let you take it over.
Thank you, Stephanie. All right. Did I do that correctly? Oops, let me try that one more time. All right. Okay. So good morning. The Health Science Building was developed as a public-private partnership with the Emerald Initiative, McKinstry, University of Washington, Gonzaga School of Medicine. It'll be a new state-of-the-art facility to house University of Washington's med school, Gonzaga's Department of Human Physiology. It'll integrate all of the medical training for the interdisciplinary of medical students, nursing students, physician assistants, and physiology students at the Gonzaga. At the SEER building, which we'll show you in the south, we'll also integrate University of Washington's physician assistant program, and then as well build upon Dean Allen's goal to create a health peninsula on the Oxbow along the Spokane River. The project team for the design of the project was CollinsWoerman as the architects, BWA as landscape architects, DCI engineers as civil and structural, McKinstry as mechanical, electrical, and fire protection. And Boughton Construction is our general contractor. Boughton was brought on early in the process to really help integrate the design team to make sure that we were on budget and on target during the whole integrated process. This really allowed the design team just to have instant feedback in terms of design decisions and costs. So I'll be moderating today, but we'll have James Walker, Owen, Eileen Link, Tanvi, Matt Allen, Jeff Urick, and Jake from Boughton presenting this afternoon. But please ask questions, and I will get those integrated as we go. James, I'll turn it over.
Okay, well, thanks, John. I'm going to take the initial portion of this presentation to show some of the project design history and evolution. This will take about 10 minutes. So the site is located just north of a bend in the Spokane River and is bounded by the Hamilton Street Bridge and Spokane Falls Boulevard. The triangular plot shown here south of SR 290 is referred to by ownership as the Peninsula. Next slide. In the foreground, you're able to see the 1907 Sear building, which was a recipient of a beautifully done renovation by McKinstry, completed in 2010. This currently houses McKinstry and other office tenants. Visible in the background there, you can see the campus of neighboring Gonzaga. Until last month, the project site housed a low warehouse structure, which has now been demolished. Next slide. Between the Sear building and the project site, there is existing infrastructure that consists of parking, east-west loop road, and a below-grade ground source heat pump system. An at-grade surface connection to Sear and its north-facing main entry was always seen as a project objective. This desired relationship began to dictate the orientation of our front door and the logical vehicle access route to both building, parking, and servicing. Next slide. In the spring of 2018, CollinsWoerman did an initial study for McKinstry, essentially confirming some basic building sizing through a number of design configurations. There was no specific program, but a general target area for the enclosed space required. Next slide. So that design contemplated a 3-story building with about 80,000 square feet. We were also accommodating close to 200 vehicles and structured parking. This was envisioned as a fairly conventional center core building with one level of below-grade garage, even though there was potential issue of a high subsurface water table. Next slide. So we looked at various straightforward configurations, and in April basically left the project with this early massing: 3 elevated floors above a single level podium that was consisted of a garage, common areas, and building support spaces. Next slide. So from the architect's perspective, the project was dormant for the next 8 months, but started again in kind of late January 2019. And at that time, the general program with overall building size was known. That the tendency would be for an academic use implied classrooms and labs, which led us to rethink the building layout. This started to give some definition to the building floor plate sizes, proportions, and importantly, core location. This is also where the partie of an elevated, kind of longer, narrow box sitting above a shorter and wider podium began to take shape. Next slide. So early design investigations always embraced a large curtain wall articulating the north facade, more or less oriented to the street and to an extent the Gonzaga campus. The interface with Sear was influencing the south side. Next slide. This led to a plan shape for the typical elevated floors similar to this, which you'll see we ultimately held onto through project completion. A number of planning items were modified. First, the central vertical transportation core was pulled outside the main floor plate. Second, the stairwells were positioned outboard. We aligned them with a central corridor, which was thought of as primarily transparent. And third, the larger span zones of the classrooms and the smaller depth areas of administrative or support spaces was established as a diagram. Next slide. The ground floor layout at that time shows the public spaces were located to the south. These spaces were seen as providing an energetic kind of socializing environment for the users in special events. These common areas would include multi-height volumes. They were south-facing and were positioned adjacent to a modest open plaza. They also included a communicating feature stair that would provide kind of an easy, convenient pathway to level 2 classrooms. Building service and garage were accessed to the east, and the covered parking layout was made more efficient with the stairs and central core landing outboard of its footprint. Next slide. The notion of a very open and transparent second-story lobby evolved. Curtain wall areas started to get some definition, and initial studies for shading devices began to occur. We first thought of rooftop mechanical equipment locations, and screening was considered as being to the north and incorporated into the massing. Ideally, this would leave the unshadowed south roofs available for possible PV arrays. Next slide. So the concept of two major forms kind of reflecting the internal layout began to take shape. And these were articulated with a larger, taller volume to the north. The west facade shows an early decision to limit glazing and consolidate it more to the north and south. Material considerations at that time included utilizing a masonry base, which might subtly reference the adjacent Sear building. Next slide. We began to consider some significant projecting canopies along the south frontage, which would also provide both overhead weather protection and some shading to the large level 1 glass faces. Next slide. At a certain point, we recognized that rotating the orientation of the elevators provided some internal benefits. We also began to consider an atrium-like vertical environment with an open feature stair connecting 3 levels. Next slide. This gives you a notion of that type of stair design. Next slide. The configuration of the tower element that houses those 3 elevators eventually incorporated a 3rd egress stair. And so the placement of that occupant-driven stair followed the logic of the others and was placed externally. There's significant glass, which allowed for kind of end of quarter transparency, views, and daylight similar to the others. Additionally, you can see here the compressed building servicing area and some designs for potential future amenities such as a roof deck and roof garden were explored. And this iteration more or less became the final design layout. Next slide. This building section illustrates that design direction for the feature stair kind of moving through the 2-story lobby, as well as you can see the 3rd egress stair to the right. Next slide. Now we recognize there were significant amounts of south-facing glass. For sensible, sustainable building operation, we either needed to shade or reduce that amount while trying to maintain an open, daylit interior environment. Next slide. So these next few images will quickly walk you through some of those studies. Here we began to consider introducing some solidity as a feature wall within the lobby facade. Additionally, we started to investigate horizontal shading elements at the smaller curtain wall areas. Next slide. We dialed back the quantity of glass enclosure at the 3rd stair. Next slide. We also began a number of studies for shading devices and the language they might instill in the south and west facades. Next. We considered differing degrees of transparency in those devices. Next. And also methods for incorporating more opaque areas into the exterior window wall system. Next slide. So we concluded with a slightly less transparent exterior skin at the commons areas, similar to this, but also incorporating the finer horizontal shading fins. Next slide. And you can see from this perspective that the interior space is still very open. Next slide. With this rendering, this was of the project from early last year. It's still a reasonably accurate depiction of the building and its context. The primary exterior materials include composite metal panel skin at the elevated levels, masonry brick-based podium, high-performance glazing, and a terracotta feature wall. So that's kind of a compressed recap of the building architecture design history. And at this point, depending on whether we have questions, I was going to turn over the presentation to Owen, who can kind of speak about the further development of solar control detail and other project design refinements.
I don't see any questions yet, so let's turn it over to Owen.
Okay, thanks, James. So yeah, I'm going to walk through the exterior of the building and talk about some of the refinements and detailing that occurred during the DD and CD phase of the project, particularly in regard to daylight control. So here we're looking at an aerial view of the north side. The building partie, as James mentioned, is clearly expressed with the 3-story metal clad and curtain wall clad volume up above a 1-story brick podium on the base. The materials, reinforce that partie with a light colored metal panel up above, large expanses of curtain wall, and then the dark colored brick base. Within that large expanse of curtain wall, we wanted to let as much natural light in as possible, yet do so in a controlled manner, while also breaking up the scale of this large wall of glass architecturally. So on the north side, we did this by using vertical fins, which are highlighted there in red, which are held off the curtain wall by about 4 inches. These vertical fins provide shading and shading in the late afternoon summer sun. And they also break up the scale of that north facade by providing a secondary rhythm within that larger massing. So you can see in this plan detail, by holding the fins off of the glass and attaching only to the horizontal mullions, we were able to space the fins at 2'6" on center, while the vertical mullions of the curtain wall are at 5 feet on center. So we worked with Oldcastle and locally here with All-Star Glass to come up with this 12-inch aluminum profile extrusion for the vertical fins. Next. So here we're looking at the south side of the buildings, south side of the building, and looking at the commons, the 2-story lobby, and the main building entry there in the middle. The building partie again is expressed in that 3-story metal panel clad volume up above, and then the 1-story brick base below. The lobby and commons area are the only 2 areas where we let that curtain wall come all the way down to the ground in order to let as much transparency and light into these spaces. Next slide. Up above, we have the same kind of large expanse of 3-story curtain wall. But here on the south side, since this is south facing, daylight control is much more critical on this side. And so we worked with McKinstry to do some extensive daylight analysis, which Tanvi will elaborate on later. But what we found to be the most effective was an external horizontal sunshade in combination with an internal light shelf, which both shades and bounces light deep into the space. So this, in combination with raising our spandrel glass sill up to 36 inches, provided the optimal daylight control while allowing as much usable natural light into the space as possible. Next. So here in this section detail, you can see that the deep horizontal sunshade and that internal light shelf. And then we're also providing interior roller shades in most locations for additional daylight control. So again, we worked with Oldcastle and All-Star Glass to make this detail an integral part of the curtain wall system. So no additional structure or anything is needed to make this work. It's all part of that curtain wall system. Next. And so here we're looking at the south side of the building again from the opposite corner. You can clearly see that south stair and elevator core tower that was pulled out of the building. And then that 2-story lobby with the terracotta feature wall there in the middle. In these areas, again, we wanted to provide as much daylighting as possible, but do so in a controlled way. Next. Since these spaces, the lobby, the stair, and the commons can handle a little bit more direct sunlight and a little bit larger temperature swings than the classrooms up above, we were able to use a horizontal fin extension, and that in combination with strategically reducing the amount of vision glazing through increased amounts of spandrel glass and opaque walls as the shading strategy on these expanses of glass. So next. So here in the section detail, you can see our shading strategy with the horizontal fins. We're using the exact same aluminum extrusion that we're using on the north side in the vertical fin application, but here we're using it as a horizontal fin that gets directly attached to the horizontal mullions. So this provides about a 13-inch overhang, which shades the vision glass below. And then again, we're providing the internal roller shades to provide that additional daylight control. Next. I wanted to quickly touch upon the site and landscape design. We do have an easement on the north side of the building, so our building is placed as close as we could get it to Spokane Falls Boulevard. And then within that easement, we are planting some large trees and some other plantings, as well as providing a generous sidewalk, which is pulled off of Spokane Falls Boulevard to allow a landscape buffer between the pedestrians and the street, as well as a kind of a landscape buffer to our building. There's also a couple rain gardens that provide, that treat and release rainwater that gets collected from the roof. That northwest corner there is kind of the front door to our building, as well as the Health Peninsula as a whole. It's where most of the students and building occupants will be coming from across the street from the main campus. So we have a nice landscape path that brings you back to the main entry of the building there on the south side. They're kind of hatched in the square pattern. You can see a nice entry plaza outside of our commons area with an operable nano wall that opens up onto that space. There's also area for a food truck to pull out and host and cater to large events that could happen in that common space, which spill out onto the entry plaza. And then also that connection, the direct connection all the way or across to the south to the main entry to the Sear building. And then finally, kind of tucked into the southeast corner is the loading dock and parking entry. So with that, I will hand it over to Eileen, who is going to walk you through some of the interior design features of the building.
Yeah, so before we turn it over to Eileen, there was a question on the exterior design and whether or not GU had campus guidelines that influenced the design.
They did not, that we followed. They, I'm sure, have them on their own campus, but this being off the campus, we did not follow those.
And I would say that we've collaborated very closely with University of Washington and Gonzaga throughout the design process. So the University of Washington has their own, the University of Washington School of Medicine has their own architect and their own kind of facilities team that we worked with, along with, you know, all of the faculty, the deans, and the students, and same with Gonzaga. All right, Eileen.
So the first floor, it's a very dynamic space with a large commons and cafe area for both the students and faculty. The vision for this space was to create a really welcoming gathering space. So it was designed to host large events and celebrations. That south exterior wall of the commons has operable doors that allow for a really large opening from the interior to the plaza. So really giving the users maximum flexibility of this space. Sprinkled throughout the first floor are several student study rooms. The medical students will often spend the majority of their day in this building, some of them even up to 20 hours per day. So it was really critical that we gave them diverse space types to retreat to throughout the day. One of the main features on the main floor is that monumental staircase. It was designed to really encourage users to use the stairs. And then one thing we really wanted to touch upon here is that large purple area. This was one of the biggest decisions that we made in the planning and programming phase of the project, was to move that anatomy suite down to the first floor. So that entire purple area is dedicated to UW's anatomy program. And although we lost a lot of parking stalls doing this, it opened the second floor and third floor up a lot. So it gave us the opportunity to put all of the classrooms on one floor and then all of the lab spaces and administration spaces on the other floor. So really encouraging collaboration and unity between the two schools. Next slide. Welcome to the second floor. So when using the main stairs or elevators, you're greeted with a really large 2-story space that's open below to that main lobby area. This entire floor is dedicated to classrooms and lecture rooms. The blue is for Gonzaga, the purple is for University of Washington. A lot of the classrooms up on that north side have a dividable whiteboard wall. So it will go from a 50-person classroom up to a 100-person classroom. So they can do really large lectures. Some of those smaller UW purple classrooms, those are for about 12 to 24 people. And what they do in there is a lot of mock clinical exam situations. The UW Student Lounge is also on this floor. It kind of serves as a secondary cafe for the students. An additional work area, hangout space, a place to eat lunch, and probably take a nap as well. This floor also has a lot of study rooms throughout. So that fits about 4 to 6 students. So it's pretty intimate. And then there's also open study nooks throughout the corridors for an impromptu study session, a touchdown space for students before class. You'll also notice that that main corridor is flanked with vertical circulation on the east and west side. And this is completely open to the exterior. So it's flooding the corridors with natural light. We designed the stairs with perforated treads to really maximize how much daylight is entering the corridors and making it a really wonderful space as you're traveling east or west. Next slide. So on the third floor, when you're using that main elevator area, there is a rooftop garden for the students and faculty to enjoy. This floor is filled with various types of lab spaces and then the 2 large administration suites. So GU's is in that northwest corner and then UW's is in that southeast corner. So this was another really big planning decision. Earlier renditions of this floor plan, they were on separate floors, but really consolidating the faculty to one floor, they thought would really promote interaction between the 2 schools. Similarly to the second floor, the study rooms and study nooks are throughout this corridor as well, in addition to a meditation room on this floor. So really giving those students moments of respite and quiet and just a place for them to refocus. Next slide. The fourth floor, it is completely shelled space for future tenants. The intention of this space is to have more biotech research and technology labs to use this space. Next slide. So early on when we were developing the interiors, we really began to dissect what should drive the interior design decisions. We knew we wanted to celebrate what they were doing in the building in a really meaningful way. And so these were some of the first images that we looked at, and they served as the starting point of the conceptual design. And they honestly still ring true to the final design as well. These images represent human health, anatomy, our region, and the simple beauty of science and learning. Some of the important things to note about these images is the importance of color. So that image on the far left, that is a DNA sequence, and every color is very purposeful and has meaning. So we wanted to use color in the building very strategically. The significance of every line in that DNA sequence is important. And so we wanted to use that same approach to the design. And lastly, we thought the rhythm of that genome sequence was really beautiful. And so we wanted to create a similar rhythm and special moments throughout the building using finishes. Next slide. So this is the finish foundation of the palette. So our goal with establishing a really strong foundation of the finishes was to promote longevity, durability, and to stay true to the community of users. The benefit of having such a strong neutral base to the finishes is it's very timeless, it's grounding, and the owner can then easily change out the accent colors that we add in strategically. Some of the finishes that you're seeing here that are prominent throughout the building are concrete, wood, a lot of neutrals that are high in texture, but variance in complexion and reflection. And then we have some black accents that kind of tie it all together. Next slide. This is an overview of our entire finish palette. So you saw the strong neutral foundation that we're using in places that would be really challenging or very expensive for them to switch, and then using color in areas that would potentially, they could change easier. So since there are 2 universities occupying this building, it was really important that we use colors that kind of represented a neutrality between the tenants. So we're not going to celebrate either school pride, but rather make the interiors more about the experience, the region, and the human health. You'll notice some of those graphic designs in the finished palette, and you'll get a really great look at those in the future renderings, but those were inspired by some DNA sequences as well. Next slide. So before we jump into the interior renderings, over in the lower right-hand corner is a floor plan that will help orient you in the building where you're at. So this is immediately upon entering the building. You're greeted with that monumental staircase in the lobby and commons. The flooring is a combination of polished concrete and wood inlay. And on that back wall, there are 3 student study rooms. You'll notice that we use accent color in there to really draw the students in. And then the ceiling is a combination of wood paneling and vertical acoustical baffles. We carved away at these 2 materials in really interesting angles that you'll see in future renderings, but it's also mirrored in the floor and how we combine the concrete and wood. Next slide. So here's a view looking into that commons and cafe area to the west. Next slide. We built a really large island sort of in the middle of this area, and it is powered throughout, so giving students just maximum flexibility, especially in the different furniture types. So we have an island, we have soft seating, we have bar seating, and then also small group tables for about 4 to 6 people. Next slide. Another great view of the study rooms. You'll see those wood slats. We put them over the glass, and we did this for a couple reasons. We loved the texture and rhythm that it created on that wall, but also we wanted to play off a lot of the transparency and porosity that you saw on the exterior and kind of bring that same design language into the interior. Next slide. Here's a great view looking back east as if you were standing at the cafe. So this is how we vision this space, really dynamic, a ton of different things going on, just a really great social hub. You'll also see to the right there that large exterior operable wall that opens up to the plaza that we mentioned earlier. Next. So here's a view at the main entry. You can see that 2-story volume space start to peek up. And one thing to note here is you'll notice that we had the green wall on that north side behind the stairs. And in the next slide, we'll show you where it ended up on the south wall. Next slide. So we moved the green wall to the south wall for a few reasons, mostly for how they're going to maintain this and access it. But it ended up playing with a really great play on the exterior window openings. And we were really inspired with the region, which we talked about earlier in the concept of the interiors. And that's how BWA kind of integrated different types of greenery to create that movement throughout the green wall. Next slide. Great view of the monumental staircase. There is a Zen Rock Garden below, again, to tie back to our concept of region. And then on the elevator wall, we're still actually working on the graphics for that, but it's going to really celebrate the river and the local region because this building sits on the oxbow of the Spokane River. Next slide. So we're going to take you up to the 2nd floor. Next. So standing at the top of the stairs, we have wood slats that go back into that main corridor. So really drawing you back into the classroom spaces. And then you can get a little bit more detail of the texture of that graphic wall on the elevator wall. Next slide. Here is a peek at the top of the stairs looking into the UW student lounge area. So it's enclosed by glass. Again, we're bringing up that same vibrancy from the cafe below and bringing this as kind of a secondary cafe space for them. Next slide. This is a typical view of a corridor. So every classroom alcove we wrapped with wood paneling, and then it has wood slats with a large room number. We really appreciated that rhythm that it created throughout the hallway, but also really creating a point of arrival for the students. So it's a very welcoming entrance before they begin their class. Next slide. This is a typical classroom lecture hall. A couple of important things to note here is that dividing whiteboard wall that creates to 100-person classroom, but then also the ceiling clouds. Those were some ceiling clouds that we collaborated with Hvac and McKinstry. They host the appliance and infrastructure for these spaces. Next slide. So the same corridor, but looking east. To the left, you'll see that series of study rooms. We put some colored glass with some transparent glass, and we really loved that rhythm that it created that was similar to that DNA sequence that we showed you earlier, but also giving them some implied privacy, but they're still connected to the corridor adjacent to them. That large message board that kind of wraps the corner of that wall is a place for students and staff to kind of tack messages and events. Next slide. Here are some of those open study nooks that we mentioned. So they are a booth style that will have powered so they can hang out there for as long as possible. On the back wall of these are some custom graphics that we created in-house, and they are truly a DNA sequence or a genome sequence that we did some abstract versions of, and you'll see how the color really came out beautifully on that. Next slide. Similarly to the study rooms, we really wanted to celebrate science. So we took a lot of, we did blood cells, skin cells, and we turned them into some really stylistic graphics. And so every study room, each floor will have a different graphic that was inspired by science. And so this one here is skin cells on that back wall. Next slide. Just another view of the study rooms, and then another classroom and then a study room down at the end of that hall as well. Next slide. We'll head up to the third floor. It has the administration suites and lab spaces. Since the overall interior design palette for the building was neutral between schools, we did really want them to celebrate their school pride and their brand into their administration suite. So University of Washington really wanted their admin suite to become kind of a hangout for the students. So this is in their, rather than having a reception desk, they kind of just wanted a living room type space for students to come in and hang out. Next slide. Within the University of Washington's admin space, this is an area where they meet with students. You can also see those 2 huddle rooms on the back wall where they can have a little bit more private conversation. Next slide. Another view of this same space, just looking east. Next slide. And then this is on the 3rd floor corridors. This is another DNA sequence, just another version of it that we decided to do on the 3rd floor. So that same open booth concept. Next slide. And then these are the entrances to the Regional Health Partnership and Gonzaga's administration suite. Next slide. And then a view of the 3rd floor corridor. And then lastly, again, the 4th floor is just shelved space for future tenants. And with that, I'm going to hand it over to McKinstry.
So for the next couple of slides, I'm going to talk about how the building performance studies influenced the design decisions for this project. So during the early design stage, we came up with climate responsive design guidelines that were considered throughout the design process. We looked at patterns for annual temperature profile, wind direction, cloud cover, and precipitation for the project site. So if you look at the chart here, there are only a few hours above 80 degrees, but then it does go all the way up to 100 degrees Fahrenheit. So even though Spokane is a heating dominated climate, it was still important for us to consider how to deal with the really hot summer months. So based on that, one of the design priorities was to have a high performing envelope and a very efficient heating plant. Additionally, the goal of the project was to reduce the solar gain because, again, in the summertime, the temperatures rises up to 100 degrees in Spokane, and also improving the daylighting quality because just like rest of the Washington state, Spokane also experiences really heavy cloud cover during winter months. The second part of the early design study was to look at the benchmarking data of similar building types in Pacific Northwest in terms of EUI. EUI stands for energy use intensity, which is the total energy use of the building divided by the building area. So the graph on the right shows different EUIs of collected medical office buildings and university buildings that range from best in class of 20 EUI to a baseline building of 120 EUI. So the lower the EUI, the more efficient your building is. So we did these studies so that before starting the project, we have a good idea about the site and where should our building energy use lie in between these bounds. Next slide. The next step for the schematic design was to study the daylighting for the block model floor plate. The building was already placed in the preferred north-south orientation. And as Owen mentioned, there was minimal glazing on the east and west facades. The initial design was to have vertical fins on both the north and the south facade, shown on the left side of the sheet. So although the vertical fins work really great on the north facade, they do not help as much on the south because they can only block early morning and late evening sun, but for the rest of the day when the sun is coming directly horizontal to the window, we needed something more that was a horizontal shading device. So again, like our goal for this daylighting study was to reduce the solar gain and improve the daylighting quality, which was achieved by adding an external shading device and an internal light shelf as shown in the section on the right. And then you can look at the daylighting maps, which show the difference in the south classrooms, where the red portion that is the direct solar glare was completely eliminated from the south classroom by using the external shading. So I guess our main goal is that the students who will be in these classrooms can have their blinds up for majority of the day because these shading devices are cutting off your glare, and anyone sitting right next to the window isn't going to be too warm that they have to cut off their views and then switch on the electric lights and therefore use more electricity. So, so I think this design definitely was able to have a really good daylighting in all the south and north classrooms. And again, like on the daylighting map on the right, about 50 to 60% of the classroom is daylit, which is a pretty hard goal to achieve with windows on only one side. Yeah, next slide. So by the start of design development phase, we had about 20 energy efficiency measures that included architectural, mechanical, electrical, and plumbing upgrades. The client and the team wanted to analyze the relevance of each energy efficiency measure, looking at a 30-year total cost of ownership study, which basically calculates the net present value of your investment. So information was collected for each measure on the first cost, the annual utility cost, equipment operation, and replacement costs. So the study was done using a TCO workbook, which is quite similar to the ELCCA workbook that the Washington State requires, and also running individual energy models to quantify the utility savings of each measure. And just for a clarification, in this project, energy modeling was only being used to make the design better. We were following the prescriptive path for Washington State Energy Code. So the graph on the right shows the 30-year cost impact of every energy efficiency measures. Some of the measures were actually having a payback of using them. For example, the reduced glazing actually has, I don't know if everyone can see it, but about $100,000 that the client actually earns during the 30-year investment of that measure. And so on and so forth. All the mechanical measures are a bit more expensive, which is why they have a higher first cost, and therefore the net present value actually has more expenditures than payback. So I think in the end, this was a good way of presenting all the information to the client and giving them the tools to make decisions based on which of these measures they would like to include into the building based on the projected budget that is granted for it. The second part of the TCO study was to take a deeper dive into the HVAC system selections, which Jeff will talk about in the next slide.
Great, thank you. Let me tell you about that HVAC system, starting with the central plant. We started off with option C, shown here, a high efficiency natural gas fired condensing boiler and air cooled chiller, all pretty standard stuff. And this was captured in the owner's project requirements, the OPR, and we used it as the basis of design through the SDs. Good efficiency, low complexity, which makes it easy to design, build, operate, and maintain. It's just a traditional approach. This design also had the lowest first cost. It wasn't the only choice, and it had some drawbacks, like putting this in a penthouse on the roof that would subtract from area available for the PV, and the natural gas boilers, while having lower utility cost relative to electricity, have a higher carbon impact and is obviously detrimental to the environment. So we thought we could do better. We pivoted to an all-electric central plant and ran a bunch of total cost of ownership options to ground, including air source heat pumps with electric boiler backup, moving the central plant into the garage, trading parking stalls for roof PV space, until we finally ended up with our chosen design, mid-DD. Like Tomby said, people can get fooled into choosing the early carrot, that first cost, but a TCO analysis allows us to present the total life cycle cost to the customer to understand the true life cost that inefficient energy solutions engender. Here, we're leveraging the Spokane Valley Rathdrum Prairie Aquifer as a heat sink to serve water-to-water heat pumps in the garage that make the heating and chilled water using electricity. The water from the aquifer only goes through a heat exchanger. It never directly contacts any mechanical equipment aside from the extraction well pumps. This system actually saves water by getting rid of that cooling tower that we would have needed otherwise. And this solution eliminates natural gas and resistance heat from the central plant, and it was actually the lowest total cost of ownership for our customer. We weren't sure we'd be able to get this permitted with the Washington State Department of Ecology, so we brought a hydrogeologist on board to help navigate that permitting process, and that's gone well. So that's the central plant. On the air side of the system, there are actually two air handling systems. There's an anatomy teaching lab on the ground floor that has a dedicated 100% outside air lab air handling unit that uses a heat recovery runaround loop to recover heat from the exhaust stream to precondition the incoming air, which saves energy. This system is dedicated to the anatomy suite, and it isolates and controls that environment just in that space. That left us able to serve the remainder of the building with a rooftop dedicated outdoor air unit that brings ventilation air to each room and 4-pipe fan coils for space conditioning. This was chosen as the optimal combination of indoor air quality, regulatory compliance, acoustic performance, comfort, cost, and constructability. Flexibility was the name of the game with these systems design. We can accommodate a range of occupancies and conditions within the space. So whether you've got 10 people in the classroom or 100, we can keep you comfortable. Whether there's a wildfire smoke event or it's flu season, we can deliver filtered air for all the occupants. These systems were designed to the latest guidance and recommendations from ASHRAE, including publications that just came out last month. So this was not a business as usual design.
In order to track the energy impact of the design, we created two energy models. One was at the end of the SD stage, which Jeff mentioned was essentially a code minimum building with an EUI of 83. And throughout the TCO process, the design was significantly improved, and we wanted to show the EUI change of eliminating natural gas for heating, introduction of an efficient ground source heat pump system with DOAS, and improved envelope assembly, improved daylighting, and added external shading devices. So with these changes included, a final energy model was created at the end of design development phase, which resulted in a EUI of 46. Which was a 45% improvement from when we started in the SD phase. And with the removal of natural gas, we had 37% carbon emissions reduction and an overall 12% energy utility cost reduction. And also in the graph on the left of the page is basically showing a pie chart of the energy end uses in a building of this type. So since it's a lab and a heavy office use building, the receptacles are the highest energy use, followed by the DOAS fans because there are really high air exchange rates required for labs again. And then the interior lighting, and then followed by space heating. So, so just to conclude, this is all to say that the design became quite energy efficient with a very collaborative process, and by leveraging energy modeling and building science to justify the design decisions that we were moving forward with.
Hi, so here's my turn, I guess, to talk about the construction side of things. Yeah, on this project, you know, the DNA of the ownership group is heavily focused on manufacturing, prefab, kind of modularized construction. You know, that's a trend we at McKinstry think is you know, a mega trend in the construction industry. And so we had the opportunity on the construction side of things to partner with the design side to get in early and do some strategic detailing to see if we could identify as many kind of prefab assembly ideas as we could on the project to try to reduce waste, refine routing, hopefully drive lower costs in the construction phase, move our work off site, which we can do more safely, and also have kind of nice, clean, accessible utilities above the ceiling that make it a nice building to service moving forward. So we had a great partnership with the design team. You know, we always want to be conscientious of the aesthetic that CollinsWoerman worked so hard to create. So there's a lot of kind of good push and pull that happens between us and the architectural teams and the structural teams, and even working internally on the design build side with our own MEP engineers to, in certain cases, modify the design to allow us to achieve some of our prefab goals. So the pictures you see on the screen are us kind of working out 3D concepts of our multi-trade rack assemblies that run through the corridor spines and the east-west corridors on levels 1, 2, and 3. And then on the far right-hand side, we, for the first time in our history, have kind of come up with a vertical multi-trade section that runs through the mechanical shaft, where we hope to drop in 3 modularized riser shaft components. And we couldn't have done this without like really, really strong partnership and trust with the design folks that are on the phone right now. We'd get into kind of good heated debates, always try to settle them with reality and using the 3D modeling tools at our disposal to kind of demonstrate where we could or couldn't make certain things happen. A lot of horse trading going on here in the design phase, but we got to some really cool outcomes and what we think is going to be clean routing in the TI spaces that also allows for prefab components in the corridor spaces as well. So on the left-hand side is really just a list that I put out there, you know, of some of the things that we focused in on, you know, with CollinsWoerman and DCI Structural, trying to, you know, make some of our concepts work, push on them a little bit, but then also receive the proper pushback when we might have gone too far, so we don't, you know, sacrifice the design integrity of the building. Next slide. So with that kind of prefab mindset, we've kind of taken the tactic at McKinstry with our kind of partners at Overcast Innovations to think about how we do modularized construction, prefab assembly, offsite in the TI world. Most of the components where people think about large prefabs in the shell and core settings, bathroom pod assemblies, overhead corridor racking, like I mentioned earlier. But with the Overcast Innovation Solutions, and specifically this cloud ceiling appliance, you probably saw in some of the renderings in the classroom spaces, we have this cloud ceiling appliance approach. It's really trying to consolidate all of the devices into a single appliance to avoid all the individual TI rough-in construction activities. You can install kind of one device and everything hooks up from the overhead utilities above. This was a great project to work with CollinsWoerman on, because this product's still in its infancy in many ways, and having a good design partner that is focused on the aesthetic, the feel, and making sure we're not compromising anything in that arena is really important, so that we create a product that you see on the screen that's going to look good in the space and not necessarily look like a hyper industrial setting. So proud of what we've done on the job thus far, and excited to move into construction and see how it gets delivered. And here's just a couple picture examples. On the left and right hand sides are installations in mock-up spaces, and we continue to refine the product. We're getting ready to do a mock-up presentation for CollinsWoerman, help us kind of further fine tune some things to make sure the ultimate product comes out on site the way we all want it to look. But in the center, you probably remember from Eileen's slides earlier, is just a still view of roughly what the clouds will look like in the space, but they'll actually have a kind of wood laminar trim finish on the bottom, so it won't be much of a monolithic white look.
So I'll let Jake talk a little bit. He's been really pushing the prefabrication of the exterior walls, the curtain walls. So Jake, you can talk about that for a little bit, and then we can open it up to any questions that anybody has.
Yeah, thanks, John, and well done for everyone that presented on many of the design topics today. Bowden was brought on early, like John said, from a target value delivery standpoint, really to provide scheduling and logistics inputs alongside the budget that we've been working on. Some of the prefabrication was started as early as the early onboarded trade partner process, using an A3 onboarding process, and really having our trade partners demonstrate their qualifications through lean construction and prefabrication. Those trade partners were brought on shortly after. It was probably about early on DD actually, and we were discussing things such as panelized wall panel systems, curtain wall systems, the insulated metal panel systems. All of those components are well on their way to prefabrication in an effort to get the building enclosed as quickly as possible to help reduce the schedule and general conditions cost. Along the way, as Tanvi and others had mentioned, many different conversations happened according to get the mechanical system that was desired. Every time we would present a system selector, there'd be several different components that would have to be selected in order to make something else work. So Matt and I joked early on about, hey, I wish there was just a bunch of buttons we could push to make all this stuff align, but very difficult, very challenging, but really fun to understand everything. And really going into construction now is making all these pieces and parts fit together from the prefab standpoint, multi-trade racks right into the exterior wall panels. So some really exciting stuff to come here.
Awesome. Well, thank you, panelists. Incredible presentation. Thank you so much. I don't see any questions. Is there any questions that anybody has, or if not, Stephanie, we can say goodbye.
Yeah, I'll go ahead and maybe close a little bit, and if there are any other questions, let's go ahead and put them into the Q&A section. I guess just an incredible thank you to CollinsWoerman, McKinstry, and to Boughton Construction for putting together all this terrific information on a project that has just broken ground and is going to be a great asset to our community. So thanks for taking the time to share with our membership and with the AEC industry. And that just brings up another point. We had about 75 people attend today. And so clearly these kinds of webinars locally produced with our talent right here in Spokane are of value. And so if you have a project, if you have an expertise, want to share, please email me. I'd be happy to get you guys on the calendar for next year. And we can continue to roll with these kinds of webinars for our community. And then finally, just a final suggestion that if you are an AIA member and want credit, please email me at office@aiaspokane.org with your member number, and I'll go ahead and make sure and give you guys credit. So looks like we do have one more question. Oh no, we've got Don Trail giving me his member number. Thank you, Don. So
well, yeah, thank you. We're all super excited to see the building come out of the ground later this year. You know, they're working on foundations now, so ready to go.
Good. Okay. Well, if there aren't any further questions, then go ahead and close. And again, thank you. And thanks to everyone who's participated. Have a great afternoon.